We are going to move on to solids that have circles in them. So there are a few types that we're going to be doing. One, probably the most obvious one, is a sphere. Okay, a sphere is basically a circle that has been rotated 360 degrees, and the area that it sweeps out as it rotates and the volume that it sweeps out, meaning the inside, as it turns around 360 degrees, creates a sphere. Okay, so that is one kind of solid that we're going to be using surface area formulas and volume formulas for. There are also circles in a cylinder. So here we have a cylinder, and a cylinder it's basically a can. Think of like a can of soup or a can of soda, or even just a tube are cans. So I am trying to represent these 3D objects on a 2D surface. So instead of writing a circle, you notice I did an oval. That gives a little bit of perspective, a little bit of an optical illusion of trying to draw out this depth, because this truly is a two-dimensional surface and I'm trying to represent a three-dimensional object on it. Okay, so that aside, I wrote some ovals, but if you were just to look straight down on it, you would just see a circle. Okay, so let's look down on this can, which I call a cylinder, and what you would see is, you would see a circle. All right, so here's the thing about circles. Circles have an area formula that a lot of us memorize but don't really understand. And so because a cylinder and a sphere and a cone, we're all going to get to those, have circles in them as part of their outsides, and we are adding up those outsides so that we can get the surface area of the entire object. If we don't know why the area of a circle has a formula for the reason that it does, we're really going to have a tough time trying to, quote, memorize these formulas, because we don't understand that the area of a circle is pi r squared for a very specific logical reason, and it's not arbitrary, meaning it is not just plucked out of just some person's mind and it didn't have a history as to how we got to it. If you understand the reason of why this formula is the area of a 2D, a two-dimensional circle, we're not even getting to solids like the spheres and the cylinders and the cones. I just want to talk about this circle which lives in each of those objects. I want to talk about this first so that we really understand what's going down with this area formula, because it just, to me, looks pretty arbitrary until you understand where it comes from. Okay, before we understand where it comes from, we need to know the anatomy of a circle. So let me go over the parts of a circle first, just to refresh our memories. I'm not saying you don't know this, I'm just trying to refresh our memories. First of all, we have a center, which I'll call center, okay? And then from the center, I can draw a straight line to the edge. We will call this the radius, or R. Okay, so the radius is a line segment that starts at the center of a circle and moves straight to the edge of a circle. Okay, that is what the radius is. The diameter is a line segment that goes from edge to edge of the circle and goes through the center. So this is not a diameter. We call this a chord. We're not going to talk about that really right now, but that's a chord. But if it is a true diameter, it goes from edge to edge, but through the center. That we call a diameter. And we'll abbreviate that as D. So radius is R, diameter is D. And then the edge of the circle is called the circumference. Circumference. Okay, all the way around is the circumference. The circumference is the perimeter of a circle. So just like a rectangle has a perimeter, if you add up all four sides, you get the perimeter. We call the perimeter for a circle the circumference. So if you call it the perimeter of a circle, that's technically correct. Not a lot of people call it that. Most people call it the circumference, okay? So I will erase the word perimeter, but just know that the circumference is the perimeter of a circle. Okay, all right, so now we've got the diameter and the radius and the circumference. These are really important. Oh, and I'll call the circumference an abbreviated C. So we'll just call it C, all right? So these are really important letters and terms to really understand, because if you can't do this completely fluently, then it's going to make everything else a lot more difficult. If you need to pause and memorize this right now, go for it. By the way, there's not just one radius. There are the plural of radius is radii. Okay, so you can write as many radii as you want. They're all going to be the same length because they all emanate from the center of the circle and they go to the edge straight out. Okay. There's likewise an infinite number of diameters that you could do. You could do all this is the diameter, okay? Do you notice a relationship between a radius and the diameter? Do you notice a relationship? There takes 2 radii to make up 1 diameter. So if you add a radius plus another radius, you get a diameter. So this is a formula, and I want us to understand how this happened. If you take a radius, which is from the center to the edge, and you put it together with another radius that goes in the opposite direction, that starts at the same center and goes to the same circumference, just on the other side, you have a line that goes clear across through the center, which again we've called the diameter. So the diameter is a radius plus another radius. Because a circle's center is equidistant from every point on the circumference, the center is truly right in the center of this shape. And if you have a radius from the center to the edge, and we have already discussed that the center is equidistant, that means the same distance any which way you go, that means that all the radii have to be the same length. And if we have also said that a diameter is a chord, a line that goes from one edge of the circumference to the other, but has to pass through the center, then the diameter is just another way of saying 2 radii put together in a straight line. Okay? So that is why if you add the distances of 2 radii, you will get the distance of 1 diameter. 2 radii equal 1 diameter. This is foundational stuff to really understand. So take your time right now. If you need a look, if you need a pause, this is a good time. Instead of saying r plus r, what you could say is 2r. So you could say that 2r equals d. Or you could rearrange that to say d equals 2r. That's totally fine. All of these are the exact same thing. 1 diameter equals 2 radii. There's yet another way to even explain it. Another way to show it is that if you take a diameter and you cut it in half, if you take a diameter and slice it into 2 equal parts, what do you have? You have 2 radii. Just like 2 radii added together equals a diameter, if you split a diameter into 2 parts, you then have 2 radii. So if you cut a diameter in half, if you cut it in half, if you divide it by 2, if you multiply it by half, These are all things that are the exact same thing. I'm just saying the same thing in a different way. Diameter that's sliced, and you just take half of it. What do you have? You have a radius. You have a radius. If you take a diameter and you cut it in half, you have a radius. So how do you represent that in terms of a formula? If you take a diameter, which we will call d, if you cut it in half, which means dividing by 2, then you have 1 radius. Another way to show it is if you have a diameter and you take half of it, which is multiplying by a half, you get a radius. So this, as well as this, are all ways to convert a radius into a diameter and a diameter back into a radius. It takes 2 radii to make 1 diameter. So if you have 1 diameter and you chop it directly in half, then you've got a radius and another radius. So if you take your diameter and you divide it in 2, you're left with only half of it, and a half of a diameter is 1 radius. Okay? This is everything that we are doing about circles is based off of the anatomy, the vocabulary meaning, and these ways of thinking of how a diameter and a radius relate to each other. In the next video, I will continue with this. All right, but take a break and digest.